Hi, in this video I'm going to talk about how to draw Lewis dot diagrams for molecules. The example molecule in this video will follow the octet rule perfectly, and I'll explain the octet rule shortly. Drawing the Lewis dot diagram for a covalently bonded molecule requires us to combine Lewis dot diagrams for single atoms. To do this, we must be very careful about keeping track of electrons, because we are dealing with several atoms at once. Here is the Lewis dot diagram for ammonia, NH3. The lines here represent chemical bonds. Each line shows that 2 electrons are being shared between those 2 atoms. The dots represent valence electrons that are not being shared with other atoms. And the octet rule of thumb is that atoms won't bother bonding with other atoms unless it helps them fill their outermost energy level with 8 electrons. But remember that hydrogen and helium prefer to have 2 electrons in their outermost energy level, not 8. Let's take a more detailed look at how to draw this diagram, and then you'll be ready to draw Lewis dot diagrams for simple molecules on your own. Using the graphic organizer shown on the next steps will be extremely helpful in keeping track of the information we need. Step 1. Write the A. Molecule name and formula, B. Names of the elements, and C. The number of atoms present for each element. Step 2. Write the number of valence electrons for each atom of each element. We can find that number using the periodic table. Step 3. Calculate the total number of valence electrons for each element. Multiply the number of atoms by the number of valence electrons per atom. Step 4. Calculate the total number of atoms and total number of valence electrons. Step 5. Write the electronegativity of each element. Sometimes we need to know which atom is the most electronegative. You find this number using a reference manual or website. Step 6. Construct a skeleton diagram by following these rules. A. Draw each atom with one bond to one other atom. B. The most electronegative atom usually goes in the center. C. Hydrogen atoms always go on the outside of other atoms. Here you can see that nitrogen, the most electronegative element, is in the center, and the hydrogens are on the outside. Step 7. Because bonds are 2 valence electrons each, subtract them from your total, and use these remaining electrons to fill in the octets for A. The outside atoms first, then B. The inner atoms. According to our table, we have to distribute 2 remaining electrons. So first, let's look at the atoms on the outside. Each hydrogen only needs 2 total electrons to fill its outermost energy level, and because each one already has a chemical bond attached to it, it has the 2 electrons it needs. Next, let's look at the atom in the center. Nitrogen needs to have a full octet, or 8 electrons, and it has 6 because of the 3 chemical bonds. So we will use the remaining 2 from our table to fill in its octet. 1, 2. Step 8. Double check that each atom has a complete octet or a full outer energy level. The 3 hydrogens are good with 2 electrons each, and the nitrogen is good with 8 electrons. That's all there is for this video. I hope it is helpful.